All right, I'm making these up, so they might not be the best examples ever, but these are what you're going to have to deal with. F of x is e to the, let's say, x squared. We'll start simple. All right, first off, if it was just e to the x, what would the derivative be? E to the x. So f prime of x is just going to be e to whatever that power is, which is x squared. Is that x? No. No. So what rule comes into play? Chain rule. So it's 2x. So all you do is rewrite it as 2x e to the x squared. That's how you make it all nice and pretty. I would prefer this. We got to stop being lazy. And I'm not saying that you are lazy. I'm just saying our answers have to stop being lazy. They have to be written in a nice way. So when it just becomes second nature. It's like learning any sport. I'm learning how to coach diving now. I've never done it before. I have to learn, and I have to learn it so it's second nature to me, which means I have to go over it over and over and over and over again. Just like any skill, over and over and over again. Do the right thing, end up in the right place. That's the right place. So, how about this? F of x is equal to 4x squared. Four to the x squared power. I'll even do that. I'll give you the rule number afterwards. That was number 12. This one was rule number 10. All right. Now, this is an a to the x, or in the rules it says, all right, it's a to the u, where u is a function of x. And so instead of saying just a to the x, which is just the simple derivative, because you don't have to really apply the chain rule, even though technically the chain rule applies because the derivative of x is always 1 and it's always there. This says the derivative of this is going to be what? The natural log of a times a to the u times u prime. This is the regular derivative. This is your chain rule. So when we deal with e to the x, if we just applied and used a to the x, it would be the natural log of e times e to the x squared times 2x. What's the natural log of e? That's 1. Because natural log and e, they are inverses. They are basically inverses of each other. If you have the natural log of e, that's equal to 1, and e to the natural log of x is equal to x. They are the values that are inverses of each other. That's why this is the general form that we can use for any number that's a. For a, e is a number. E is 2.718-ish and change or something like that. 2.717, something like that. It's defined totally different, and now that we know the limit, we could actually define it, but we haven't defined it yet. We'll define it in a little bit. For this one, f prime of x is going to be, I have a 4. I need a natural log of 4 times 4 to the x squared, because whenever you have any number to a power, that has the variable in it, it's going to be that value, and then I have to chain rule it, which would be 2x. So to write it in the proper way, I'm just going to put the 2x out front. 2x times the natural log of 4 times 4x. Why would it be? Because I'm just taking the derivative of 2x squared. The 4 doesn't come into play because that's a. And if you notice here, it's just u squared, which means take the derivative of the exponent. Does that make sense?
So always when it's to the x squared power, it's always number 10, the rule number 10?
Yep.
And if it's with a number, it's always number 12?
It's always number 12. So another example on that line, f of x is equal f of x is equal to 150 to the 3x to the 4th power. Now, don't look at this and freak out. Remember, it's just a formula that we have to do now. It's a number to a power, so I need a natural log of a number. What's the number? Same rule. So what am I going to take the natural log of? 150. Do I care what the natural log of 150 is? No. This is an exact answer. Keep it there. Now, I just rewrite the function, 3x to the 4th, and then I'm going to take the derivative of the stuff up top, 12x to the 3rd, and then I just rewrite stuff. Like 12x to the 3rd times natural log of 150 times 150 to the 3x to the 4th. And I always put the function last anyway, just because all this stuff is kind of like just noise from the function. I can look at the end of this and see what the function actually was. So if I said this, and I said this is your derivative, what's the original function? Which is something we're going to be doing in a couple weeks. Because now that we've taken derivatives, we have to go the other way. Which ends up being your integrals, but they're also called antiderivatives. Because they're undoing derivatives. Here, I need you to be able to notice that, I have a natural log of a number, and I have what looks like could have been a chain rule, and then I have that a to the u power. So that's my function right there. And then there could have been a constant, couldn't there? Because what's the derivative of a constant? 0. And here's just something that preview of coming abstractions. Anytime you do an antiderivative or you do an integral, when you're trying to find what the original function is, there's an infinite number of them. Because you can always add a constant to the end of it. Because the derivative of a constant is 0. So you don't know what that constant is. But you could have said this is 150 to the 3x to the 4th power plus 10, plus 50, plus 90, plus a billion if you wanted to. If you wanted to totally be just one of those smart aleck math students, you could have said plus 5.2 times 10 to the negative 750th. You could have done something like that, and I would have said, ha ha ha, very funny, but you're right. But the idea is, since the derivative of a constant is 0, and if you're going backwards, and I know this has nothing to do with the quiz, so you're saying to yourself, why is he even talking about it? Since the derivative of the constant is 0, we don't know what the constant was. The constant could have been 0, or it could have been any of the real numbers. Preview coming attractions. How about f of x is equal to the log base 5 of x squared? Don't yell it out. This would be rule number 11. What any good amplifier should be turned to. No. You guys get no rule charts, you get no formula sheets, you get nothing. Sorry, because on the AP test, you get no formulas, you get no rules, you get no nothing. And barely, it's not mean, it's just you got to know your stuff. Welcome to the real world. So far, we only have 18. Yeah, thank you. All right, now rule number 11 says, all right, if I have a log, what do I do? All right, it's going to be a fraction. Is there a number here? Yeah, the number's 5. I'm going to take the natural log of 5. And then, underneath it, I'm also going to multiply it by u. U is the x squared. It's the variable part of it. So it's going to be x squared. Now, the chain rule goes up top. What's the chain rule for x squared? 2x. So then, and this is how I want to see it. Because I want to see that you have the natural, this is the natural log of a, this is u, and this is u prime. And then you simplify it. In the top, you get a 2. You have x, 1x in the top, 2x is in the bottom. So I have an x in the bottom, and then multiply it by the natural log of 5.
So you just divide the 2 x's out?
Yep.
Okay. So what you do?
Divided it out.
Then what out?
The x's.
I had it 1x there, 2x's down there. Now, here's a cool thing. If you know your e to the x rule or your a to the x rule, which is the natural log of a times the function, that's for the natural log, correct? No, that's for a to the x. Now, the natural log and the log are the inverse of those. So, if you have, for example, f of x is equal to a to the x, f prime of x is equal to natural log of a times a to the x with the chain rule if you need it, right? Now, if you have f of x is equal to the to the log base a of x, f prime of x is going to take this same information and put it in the denominator. So, I know there's a lot of rules, but if you kind of think about the relationship between a to the x and log base a to the x, the derivatives are almost identical to each other. One's just the reciprocal of the other one. The log has more stuff, and a looks like, and the way that I always remembered it is a is a subscript, so all that stuff goes in the bottom because that a went into the bottom. I mean, that's a silly way of thinking about it, but it helped because then it told me, oh, I got to put everything in the bottom. But then the chain rule, because we always multiply by the chain rule ends up in the top.
What's CR?
Chain rule.
Oh.
Yes.
So you guys said you did log 5 x squared whatever, and then on the denominator you put x squared and you did 5. You only put the a
I screwed that up, didn't I?
What?
No, that was right.
Oh,
If you use x squared, it shouldn't 5 be there. 'Cause then down there, that's what I'm saying. Is there an a there or just an x? Okay, you're not wrong.
yeah, I screwed that one up. But the idea is still the same.
Oh.
So the right answer is just the x at 5.
You don't put the a to the x. But the relationship between the two of them is still the same. You just have to remember, oh, a to the x, I got to put an a to the x. E to the x is e to the x. A to the x is a to the x. But when it's generalized, you have to put the natural log there. Here, it's generalized, you put the natural log there. And this kind of works also. Sorry if I confused you on that one. That was the right answer. Now you don't put a to the x, you just put x. Because there is no a to the x in this one. And it's like if you have f of x is equal to e to the x, f prime of x is actually equal to the natural log of e times e to the x. That's what it really is. But what's the natural log of e? 1. So that's just e to the x. That's where it comes from. If I have now f of x is the natural log of x, what's f prime of the natural log of x, which this is number 9. It ends up being 1 over x, which will end up being, if there's a chain rule, it'll go right in there. Just like we would multiply this by the chain rule, you multiply this by the chain rule. But the idea is similar to the a to the x and the log. E to the x and the natural log go together. So if it's e to the x is just going to be e to the x, the natural log of x is just going to be 1 over the natural, or 1 over x. And you just end up doing the reciprocal, essentially the reciprocal of what e to the x was. But since there's not e to the x, we just use what we got. So I know they're not exactly 100% the same, but that's a good rule of thumb to remember the relationship between e to the x or a to the x and either log or natural log. And e to the x is e to the x. Natural log of x is 1 over x. It's the reciprocals. And since they're inverse functions of each other anyway, they're inverses of each other, one should be the reciprocal, while one shouldn't be the reciprocal. Or if you want to think about, I know I don't want to throw around the word opposite, because opposite we like to throw negative signs, but this is kind of like the opposite operation than this. This is like multiplication, this is like division. No, this one's 11, I think. E to the x is 10. That's number 10, and this is number 9. But they go together. So if you think of them as going together as opposed to two separate rules, and even though there's just a little bit of difference between them, you're going to be in good shape. Yes?
Why can you solve number 10 in 2 different ways? Because you first solved number 10 in 2x times e to the x squared, and now you solved 10.
Well, I just had e to the x.
Yes.
So if you do a chain rule of this, what's the chain rule of x?
Oh, okay.
Chain rule applied to x is just 1.
It's
So
if you have like x to the, I don't know, second, third, fourth power.
right.
Then
Which is why I always say, if you do the chain rule all the time, it's always going to happen. Because then if I do a chain rule, what's the derivative of x? 1. That's your chain rule. That's just
so
That's just dx dx, which is 1.
So would it be wrong if we would do it with the chain rule?
If you did that with the chain rule and you put a 1 there, I wouldn't care. That's good that's good. That tells me you understand the chain rule. That makes me happy teacher. I'll send you all the happy face emojis and everything, if I knew how to send them, and if I knew your number. But I don't know your number, and I don't want to know your number. I'll send it out to the entire class on Remind. I have to take a picture of them, though. I'm just having a bad day. I'm just tired. It's been a long, stressful, emotional week. I don't know. What are you talking about? You're just pointing at the screen and saying, what's that the derivative of? This? That. You guys are all going to go home and say, 1, this teacher should get fired because he's an idiot. And because he's an idiot. And the weird thing was, after my banquet, I had my day of decompression. I got home and I had to take my daughter to the emergency room and stayed up till 1 o'clock. And it ruined the rest of the week. And this is what you get when you have an emotional 5 days, and then after you can relax, and then you got to take your kid to the hospital. This is what you get.
It makes you feel better. You're better than my last math teacher. Couldn't explain it.
Who was your last math teacher?
Oh no, I live in Germany, and he was an AP math teacher, and we had no AP math, and he taught us on the level of AP.
And couldn't explain it?
No.
Oh, well then, thank you. I appreciate that. All right. How about if I give you the tangent of x squared plus 3x plus 7? Ha-ha! I will tell you this is rule 15. We'll call this R15 or 15R. No, because you're probably right. That is a 15. Because that's life. Life isn't handed. Life is not an A to B to C operation. It is. Yes, sir. No, I didn't even touch them. No, I'm going to work on them this weekend.
That sounds like a great idea.
E for effort? What? All right, let's do the derivative here. What's the derivative of the tangent? All right, if you remember this, if you remember tangent, S and T's go together. The tangent and the cotangent end up being something squared. So if the tangent, secant goes with tangent because S and T are right next to each other. Now, you just end up putting the angle that they give you. And then we've got to multiply this whole thing by the chain rule. 2x plus 3. And then, to make teacher happy, 2x plus 3 out front. Because we don't ever, and this is where it's more important than with other things. If you have a number, if you're taking a trig value and then you're going to multiply it by something, multiply it, put the multiple out first. Because otherwise, the biggest mistake I've seen is people have included this value in with the angle. And then it changes the entire problem. So that's why I want you to start putting stuff in front of what the actual function is. So there's a reason for it, and it's to avoid mistakes that we should be able to avoid. So this ends up being secant squared of x squared plus 3x plus 7. All right. How about f of x is equal to the cosecant of the sine of x squared. It's a double C in two different ways. Let's see. What rule is this? This would be a combination of rule number 18, rule number 13, and then no, those two rules. Those two rules. Someone should play taps. Thus ends an era of my life. Now, if you get... Do you see that there's a function in a function in a function?
Yes.
Yeah.
Alright, there's a lot of stuff. So, there's going to be... When we said double C, not only is it double C because it's a cosecant, it's a double C because it's a double chain rule.
So it's a quad C.
It's a 4C. Yeah, it's a quad C, which sounds like an engine, doesn't it?
Yeah.
Alright, so f prime of x. We start with the cosecant. The derivative of the cosecant.
Of sine of x squared.
Oh, you got to do this.
Oh no.
No. It's just because you have to do this. You have to say this is going to be equal to the negative cosecant of the sine of x squared times the cotangent of the sine of x squared. Because you can't just say cosecant times the cotangent. Because you have, whenever you have a trig value, you have to put an angle with it. Yeah, like if this is u right here, if you have the cosecant of u, if y equals that, y prime is equal to negative cosecant u, cotangent u, then u times u prime. All right, so now we have to take the derivative of the angle. What's the derivative of the sine? The cosine of x squared. Now we got to take the derivative of the x squared, which is 2x. Yeah. And then we do some cleanup. I just put the negative 2x out front, and then because there's a negative sign out there, and so I put the negative first. Then I put the 2x, and then it doesn't matter because there's the cosecant of the sine, the cotangent of the sine, and the cosine of x squared. Doesn't matter how you write it. And if you just look at this and say cosecant of sine x squared, I like to put things in a lot of brackets because it helps me. If you don't, make it clear, because remember, your idiot teacher is the one who's going to be grading this. So you have to make sure that I'm able to recognize what's going on. So please just make it happen for me, to make it easy on me. You always want to make it easy on the teacher. We haven't done any absolute values yet, so don't worry about the absolute value one yet. Is there any... That's rule number 8. We haven't done rule number 8 yet. And that's why we skipped 31 or something in the homework. Even though you could have graphed it and found the maximum anyway. I would say that if limits are 20, then derivatives are 40, and integration is 40. It's it is, but it isn't. Um, it is in the sense that you're able to go from this monstrosity back to this, although you wouldn't want to. This isn't that good of an antiderivative or an integral problem, but you also get the idea that, like, if you take the integral of a velocity, you figure out how far you've actually traveled, something like that. So the applications are different than what we get from derivatives. How much of it is physics? Physics is just an application of calculus. I can't. That's a question I can't answer. You have to go with the situation at hand. Yes. It's a good mix. They're like, this one's a crazy one. You might see something like this once. No, it's usually I will be getting a AP Calculus, and I recommend that anybody taking the test goes and does this. Go to a bookstore and pick up they're usually about $20. An AP Calculus study guide for AB, and it usually gives you about 6 to 8 tests. And get the one with the CD because it's usually not any more expensive. And then you get online tests, and it goes through every section, and it gives you a good study review and a lot of study problems and things like that. I'm going to go and pick one up. I'm going to look through them. I'm going to get the one with the most practice tests in them, and I'm just going to be giving you problems off of there. Yes. And we're going to do that. I've been talking with Mott, and I'll get with Cosno. We're going to open up on a Saturday, and we're going to get all the AP Calc kids together and just do this for all the AP Calc kids. And it'll be a good starting point for our review. So we'll do that kind of after we learn everything and before we start reviewing for the test.